That formula that we put in your toolkit entry is also on your notes. So if you notice where it says percent of change equals amount of change over original times 100, that's the formula that we put in your toolkit. There is a second one, and it is an equivalent equation. It means the same thing, but instead of putting percent of change over 100, they multiplied both sides by 100 and stuck the 100 over here. Okay. Some are easier. If you're looking for percent of change, this is going to be the formula you want to use. But if you're looking for, let's say, the original amount, so they give you the percent of change and you want to find the original amount, this is going to be the easier one to use. So that's why there's two on there. Okay, most of the time we're going to be using that first one. And like I said at the beginning of class, most of these are just plugging numbers into a formula. Okay, I don't think today is too tricky. For that first part, we want to identify the change as an increase or a decrease, and then I want to actually find the percent of change. So I'm going to give you two numbers. So for this first one, if I give you 220 and 253. First, is this an increase or a decrease? Okay, it's an increase, right? So we're going to go ahead and say this is an increase. It is getting larger. Now I want to find the percent of change. The first thing that you need to find the percent of change is you need to tell me how much it actually changed. I just want a number. How much did it change? 33. So the amount of change is 33. From 220 to 253, changed 33. So to find the percent of change, you are going to put that amount of change over the original. It's very, very, very important. You have to put the original in the denominator. So in this case, I'm going to put 220 in my denominator. Whatever that is, I'm going to multiply it by 100%. Or move the decimal 2 places to the right because I want a percent, not a decimal. When you actually divide up 33 over 220, you should get 15/100ths. So what is my percent of change?
What do you divide that in?
I did it in my head. I have the answer. No. It should be 15%. I'm just going to give you the division answers unless you guys want to work them out.
No.
In essence of saving time. So, okay. Yes?
When you write the answer, do you have to say if it's an increase or decrease?
No. Unless I specifically ask you, you do not have to say percent increase of 15%. Most of the time I'm just interested in whether or what the actual percent of change was. Okay? So for the most part, it's just plugging numbers into a formula. Okay, questions on that first example? All right, I want you guys to try this one. If the original is 60 and the new is 45, is this an increase or a decrease? Decrease. Okay, this one is a decrease. Now, Connor had a good question. He said, well, do you write a negative? Once we identify it as a decrease, we just want the amount of change. I want to know how much it changed. So you're still looking for the difference between 60 and 45, and you're looking for a positive number. What is the amount of change from 60 to 45? 15. What did you put in your denominator? 60, right? We always put the original. Now, I said that in our bell work that if you can simplify your fraction, a lot of times it's going to make life easier. In this case, it makes it a lot easier. How can you simplify 15 over 60? Okay, you can divide by 15. Whenever you divide by 15, what is your new fraction? 1/4. What is 1/4 as a decimal?
0.25.
0.25. And what is 0.25 as a percent?
25%.
25%. So it's a 25% decrease. All right.
Google Classroom.
Okay. Let's look at a couple word problems, and I have one that we're going to put on the back of your notes because I want to make sure I cover all the different types of examples. All right, an alto saxophone was for sale for $500 on Black Friday. It went on sale for $440. What was the percent of change? Okay, exact same way we did the last two examples, except now you're just going to have a dollar sign along with it. Doesn't make a whole lot of difference. I still need to know the amounts of change. So, first, is this an increase or a decrease? I hope it's a decrease, right? If it's a sale, it'd be a pretty bad sale if it was an increase, wouldn't it? All right, so my amount of change from 500 to 440 is what? 60. What is my original amount? 500. Okay, so I need to figure out what 60 divided by 500 is. Whatever that is, I'm going to multiply it by 100%. All right, whenever you divided 60 by 500, what did you get? Okay, so you got 0.12. We need to take that times 100%. So what was my percent of decrease? 12%. It should have been 12%. Maybe you switched your numbers, so instead you took, I'll look at it. Okay, if I give you an original and a new, do you think you can find the percent of change? Yes. Okay. If you're given the original and the new and you're asked to find the percent of change, that's pretty easy because it's just plugging numbers into a formula and dividing and multiplying and all that stuff. How it gets tricky is if instead, like in this example, I'm given the percent of change and I'm asked to find the original price. You're going to set all of these ones up the same way. If it asks you for the original price, you're going to use that second formula that we talked about at the very beginning of the notes. So where I had the percent of change over 100 equals amount of change over original. Okay, so same proportion that's up at the top. It's going to be easier whenever we're trying to solve using this one instead of the other one. So I'm going to go through it. I'm going to fill in the blanks, things that I do know. Because in this case, I don't know what the original price is. That's what I'm looking for. So for the very top part, do I know what the percent of change is? 20%. It's 20, right? It's 20. So instead of percent of change, I'm going to write 20. And I have 100 in the denominator. Okay, left side of my proportions taken care of. Now, do I know either the amount of change or the original? Oh, I don't know either one of those, right? Because I don't know if I knew the original, would I know the amount of change? Yeah. Yep. If I had the original amount, I could find the amount of change, but I don't have the original amount. So what you're going to do is you're going to let the original amount be a variable. So pick a variable. I usually use X. I'm looking for my original amount. Now I need to find a way that I can represent amount of change using X. Because I don't want to use another variable because I'm not going to be able to solve anything. So I want you guys to think about the last couple problems that we've done. How did we find the amounts of change in the examples before? Julian? What we subtracted, right? We subtracted the original and the new. Isn't that what we did? Why can't we do that with a variable? Can we do that with a variable? Can I take X minus 32? I'm still taking my original minus my new. I just don't know what the original is. Now, that's why I say that you're going to set this up every single time this way. The reason why it's going to be X minus 32 and not 32 minus X, you'll get the same answer, except you're going to get a negative answer, which is a negative price, which doesn't really make sense. So if that happens and you forget, you'll get a negative price. So it just means you should switch them around. The reason why we put X first is my original is larger than my new, isn't it? Now they don't because this is subtraction. If this was an addition, or sorry, a multiplication, it would. Okay? All right. Now if I have a proportion, how do I solve a proportion? Cross products. I'm going to set my cross products equal to each other. I have to take 20x. I'm going to set it equal to 100 times x minus 32. And when I solve this, I have 20x equals 100x minus 3,200. Okay, I have x's on both sides of my equal sign. What should I do? Nope. Yes, subtract what? You could go either way. You could get all the x's on the left side, or you could get all the x's on the right side. You'll get the same answer either way. I'm going to go ahead and move them over to the right side, so I'm going to subtract 20x from both sides. When I do that, I end up with 0 equals 80x minus 3,200. What would you do to solve for x?
Add.
Very good. Yes. Add 3,200. So now I have 3,200 equals 80x. Divide both sides by 80. So x equals 40. My original price was $40.